So we finished off looking at example 8. I like example 8, I like example 8, I like example 8, example 8 is the next question. How many of you have ever stood on a cliff and had a good echo where you could shout something and there was a delay and then you would hear it come back, maybe even hear it come back a second or a third time? Have been to a really good echo place. They're fun. The inner child within me, I'm yelling stuff along with everybody else, especially if there's a nice long delay. And then you hear the echo. And then you hear another echo. Those are cool. Is there a way that you can figure out how far away whatever you're bouncing off of is? Yes. Or in this case, is there well, read along with me. It says this: the speed of sound is 330 meters per second. It varies. The speed of sound is around 340-ish, but it depends on the humidity and the temperature and the altitude. It varies a little bit. I usually use 333 because that's a number that I can remember in my head because it's 3 3s and I'm enough of a nerd. Anyways, we'll use 330 because that's what the question says. Sheldon is shouting at the base of a steep mountain. If the mountain is 420 meters away, how long will it take before Sheldon hears his echo? What's this question asking me to find? This is that DFIC approach that I was introducing you to last day, where I always start out by listing my data, and what I always start out is saying, what are they asking me to find? Well, the question is how long? How long is a bit tricky, because if I say to you, how long was the movie? What am I asking? Time. If I say to you, how long is the football field? So I'll do that on purpose sometimes just to give you a nice vague question. On a test, I'm almost always more specific. Looking at this question, is that how long asking me to find time or distance? How do you know? You're right. There's kind of a grammar there, but also I'm going to argue I don't think they're asking me to find the distance because they gave me they're not going to give me the answer and ask me to find they're not. So time. So all of us, we're going to write down and then, Allie, I said yesterday, we're going to read the question looking for numbers. What's the first number that you see in the question? I think I said last day, physics word problems are way easier than the stupid math ones that you do because, Billy is 2 years older than Susie 5 years from now. Those are stupid. They're a waste of time. They really are. But physics ones are more useful. What's the first number you see? What are the units right next to it? What are the units right next to it? What's an M stand for? Oh, that's okay. Taylor, what are the units next to it? Meters per second. So Taylor, what do I measure in meters? I think I said it's worth memorizing what units go with what because it really cuts down on your thinking. What do I measure in meters per second? Time? So you know. Distance? So you know. What is that a measure of? It's the third one. What's left, folks? There's a hint. It actually uses the word in the question. Speed. Okay? What symbol do we use for speed? What symbol do we use for velocity? What letter? So don't write this. Write the V down. With the vector was velocity. Without a vector was speed. Right? And let's write down 330 meters per second. Is that okay, Allie? Because I'm coming back to you. What's the next number that you see? What are the units next to it? What do we measure in meters? Time? Say no. By the way, what are the units for time? Seconds? Or hours, but we'll probably do a conversion. What's meters a measure of? And this is a distance, not a displacement. So we're all going to write D equals 420. On your green formula sheet, you have an equation somewhere near the top, I think in the first row, maybe the second row, that has a D and a V and a T in it and nothing else. Find it. Well, there's two, Mr. Dueck. Yeah. So find the one that has the T by itself. There isn't one, Mr. Dueck. Okay. Find the one that doesn't have the T on the bottom. Have I narrowed it down enough for you to figure? I'm hoping you were looking at them and your eyes are moving back and forth. Which equation, Emily? D equals VT. Yes. And that's how you'll read it. Don't worry about velocity. Just read the letters. We're going to abbreviate, even in our verbal. Okay. What am I trying to find, Emily? What has a question mark next to it, Emily? What am I trying to find, Emily? No one noticed. Okay, scene 1, act 1, take 2, and action. Emily, my angel, clever young lady, what am I trying to find? I knew you'd get it first time. Okay. I want to get the T by itself. What side of this equation is the letter T on? The left side or the right side? So the left side would just drop down like a domino. Ka-chunk. Now, right now, I know some of you are saying, Mr. Dueck, why can't I just start plugging in numbers? I told you, don't quit on me. You're not going to plug in numbers. That's going to be the last thing we're going to do. I'm going to teach you how to rearrange stuff up here first. So the left side drops down like a domino. In my mind, don't write this down. I'm imagining that the equal sign is dropped down, but I'm just going to imagine that it's there. What else is next to the T on the right-hand side? What other letter is next to the T on the right-hand side? The V. See it? See it? Yeah. What's the V doing to the T? Is it adding? Say no. If it was adding, how would I move the V over? Yeah, your math 8, your equation solving, the same rule. Do the opposite. If it was subtracting, how would I move the V over? Add. What is the V doing to the T when we have two letters side by side? What mathematical operation is that? So what's the opposite of multiply? In other words, timesing by V on the right is the same as dividing by V on the left. And then look up for 1 second, all of you. In our Sesame Street imagination, don't write this down, we'll remember equals T, but do you mind, Emily, instead of D over V equals T, I'm going to go T equals D over V because that's where we're used to having a thing by itself. This may seem complicated. It's not. We'll get there. Allie, coming back to you. What's D? And this is why we made our list, because now we're at the plug and chug stage. As a number, what's D equal to exactly? Psst, psst. What's D equal to exactly as a number? This is, and if you didn't write that list down, you need do it. You didn't, did you? Do it my way. No shortcuts. What's D equal to, Allie? Good. What's V equal to? And the other thing that I did is I double-checked the units. Taylor, what were the units for the speed? What per what? Meters and seconds. What were the units for the distance, Allie? Those units match. If I had 1 in kilometers and 1 in meters per second, or if I had a speed in meters per second and a time in hours, I have to do a conversion. I can't do math with different units in the same question. But this is going to give us an answer in seconds. What's the answer, folks? Oh, I guess technically I have 2 sig figs, 2 sig figs. I should go to 2 sig figs. I'm going to go to 3. What's the answer, Sky? Now, I warned you were away. I warned you all last day. When I say what's the answer and I don't see you typing on a calculator, I'm coming at you. That means you're not participating. So by now you've typed it into your calculator, right? 420 divided by 330. This is how we roll. Jeez, Dueck, you're intense. Oh, you have no idea. That's a typo, Mr. Dueck. Did we all get 1.272727? That there? Is that right? I'm going to write 1.27. And now, you ready for a candy? This is wrong. Can anybody for a candy tell me why this must be wrong? Even with an S next to it, it would be wrong. Can anybody for a candy tell me why this must be wrong? Karn? Nope. I rounded off properly. I could go 1.3, but I went to 3 sig figs. This 1.27 repeating is the wrong answer. Why? Yeah. Nope. Read the question carefully. Tell me why this must be wrong. Yeah. No. Seconds, I'll put it there when I need to. This number, the number 1.27 is wrong. Talk to me.
That's only the distance it will take for the sound from 2 down, not back.
It's got to go there, and now I see a whole bunch of you. Oh, yeah. And that's kind of why I like this question, because it's not just a straight plug and chug, turn your brain off Math 8 question. It's now you have to interpret, does this make sense? So what are we going to do with this number, Davis? Matthew, I've done that now twice. I'm sorry. Matt, what am I going to do with it? Matthew, what am I going to do with this number? You all still have this stored on your calculator, yes? So I'm not going to times 1.27 by 2. I'm going to write that, but of course, I'm just going to hit my times button, which for all of you should bring up your answer feature. 2. Come in. Give me 1 second. Let me pause. 5, 4, 5, 4, 5, 4, 5. And I hope you've clued in that I think it goes on forever and ever. But I'm going to go to 2 sig figs. Will it be 2.54 or will it be 2.55? There's where I'm rounding to. What's next to that 4? So is that 4 going to stay a 4, become a 5? I would take a snotty half mark off if you told me the answer was 2.54. We round off properly. We don't chop off. We round off. 2.55 seconds. Now, let's suppose, those of you that have stood at a cliff before, let's suppose instead of knowing how far away the cliff was and figuring out how long it would take, really what you would do is you would time how long it took to hear the echo. If you knew the time and the speed of sound, could you figure out how far away the cliff was? Oh, heck yeah, and I've done that before. It's kind of fun. Although usually if I'm doing rough math, I just use 300 instead of 330 because I can multiply by 300 in my head pretty easily. I will eventually teach you how to figure out, for example, if you're standing in line at Playland, how to estimate how fast you'll be going at the bottom of the first hill in the roller coaster. I think that gives you something to do when you're in line, and I think it adds to the experience. Dead serious. Absolutely. Huh? No. It's not hard at all. Believe it or not, it's almost all your 10 times table. I swear to you. Works out. The universe works out pretty nice sometimes. Jack, you ready?
Yeah.
Read along with me. It says this. Jeremy is driving at 18 meters per second. What are the units next to that 18? So what is that? Time? Say no. What's meters per second? I'm already making a little mental note. There's a V. Don't write it down, but there's a V. If he drives for 2.5 what? Say it again. 2.5 what? What was the speed? Meters per what? Ding, ding, ding. I'm going to have to do a conversion. I can't do math with something that has seconds and another number that has hours. I'm either going to change 1 into hours or more likely change hours into seconds. How far will he travel in A, kilometers, B, in meters? Okay. When they say how far, Jack, what are they asking me to find? In terms of the 3 letters. Now, you know what you might want to do at the top of this page right now? You might want to just put D equals VT. You can put the vector on the D, you can put the vector on the V, because it works for displacement and velocity, and it works for distance and speed. Why didn't I put a vector on time? Time is a scalar, so no vector sign, okay? So, can I abbreviate? What's this question asking me to find, D or V or T? When it says how far? D. So you ready? First thing I'm going to do, since there's a part A and a part B, I'm going to go A bracket because I've written something down. What do you say they're asking me to find, Jack? I'm going to go D equals question mark. I've written something down. I feel better. Eventually, we will get good enough that we'll start to skip steps, but I'm going to be fussy, Allie. I'm going to insist you're going to do it my way until you're getting 100% consistently, okay? What's that 18? Do you remember? Which letter? D or V or T? But I'm going to write the units because they're yucky in that they don't match the other ones. Just to remind myself, dude, check the units. What's that, 2.5, Jack? Yep. Now, they want us to find how far in, what does part A say? Elias. Okay. I can either look up, change, where's my little pointer? There we go. Change this to seconds. That will give me a distance in meters because I have meters, seconds, and seconds. The distance unit that's left behind Tito is meters. Or I could change this to kilometers per hour. It was something to do with the 3.6. And that would give me an answer in kilometers an hour. That would give me an answer in kilometers. I'm going to do that. Rather than changing this time into seconds, I'm going to change this into kilometers per hour. So where it says V equals, right underneath that, I'm going to write V equals. How do I go from meters per second to kilometers per hour? It's something to do with the 3.6 on my green sheet. Which one? Times? And you wrote a clear indication that you can figure out what we're getting. So can you go on your calculator, 18 times? You know what? In our notes, look up. In our notes, let's write it. In your homework, if you went straight to your calculator and just wrote the new number, I'd be fine with that. But in our notes, let's write that we did that so that when you're studying later, you know what the heck we did. 18 times 3.6. 18 meters per second is 64.8 kilometers per hour. Jack, what are they asking me to find? I'm looking for an equation that has a D, a V, and a T in it. Psst, there is one. And it's is it second line down, second one over on your formula sheet? That one. Now, that equation actually, in a couple of days, we're going to stop using. That equation doesn't let us hit the brakes or step on the gas. It's boring. There's a broader version of that includes acceleration. You might even see it a couple of lines later on, further down. Then we'll be able to speed up and slow down, and we'll start to use that as our default equation. But for now, read me the equation. And then I would say to you, I want to get the D by itself. Oh, the D is already by itself. Cool. What's V in this question, Jack, my friend? Ah, good catch. Thank you. I was almost hoping that you would do that. What is it? Now I want you to notice if I write 64.8 and if I put the units in times, what's the time? Look up, everybody look up. Do you see how the hours cancels because one's on the top and one's on the bottom? What are the only units left behind? What did I want this to be in? I think I said when I taught you unit conversion that these chains are like breadcrumbs. They'll tell you you're on the right track. The fact that I wanted an answer in kilometers and I get an answer in kilometers, I think I did it right. That's how I pulled off that third-year calculus chain. I knew I wanted an answer. I knew the units for my answer, and I built a 10-long chain that ended up with the units for my answer. And I figured, it's got to be right. I'm going to go answer button times 2.5. How many kilometers? You had 162? You know what? I'm not going to round off. That's a nice number. It stops. I'm going to go 3 sig figs, 162. Units, Jack? Yeah. Whoa, careful. Just kilometers. I would have taken a half mark off, and I would have said, hey, don't be sloppy. Cool. Draw a little line. What's part B want us to find? The distance in. Has anybody figured out the short way to go from kilometers to meters because you have your driver's licenses and maybe you should know this short way? What do? I heard it. No, that's from meters per second, kilometers per, yeah. Divide by 1,000? Yeah, 162 kilometers is not 0.16 meters. And that's honestly how I remember. Do I divide or do I times? It must be times. Okay. Add 3 zeros if you really want to take a shortcut. Times by 1,000. You could build a chain and that would work too, but sometimes it's nice to have a shortcut. All right, some thought puzzles. True or false? An object can have a positive distance while having a displacement equaling 0. Think to yourself. Don't blurt out an answer. With an election coming up, we're going to vote. How high you hold your hand up is how sure you are of the answer. I'm positive. I'm pretty sure. I'm only voting because Mr. Dueck will make fun of me if I don't vote, and Mr. Dueck will make fun of you if you don't vote. The only rule in my class is you have to have an opinion and make a hypothesis. I don't mind a wrong opinion or hypothesis because we can learn from mistakes too. But if you don't even make the effort, then I'll get grumpy. Okay? So an object can have a positive distance while having a displacement equaling 0. Who says true? 1, 2, 3. Ooh. Everyone. And then what I usually do is I say, convince me. You can either attack someone else's answer as being wrong. Oh, I know there's wrong. Or you can defend your own answer as being right. Quinn, you said true earlier. Convince me. Here's what you just said. You can have a positive distance while having a displacement equaling 0 by having a positive distance while having a displacement equaling 0. We call that circular reasoning. Give me an example. Okay. 3 meters forward, 3 meters back. There. One example, good enough. It's possible. By the way, do you see what I meant with your first explanation? You know, it's like I'm stupid because I'm dumb. Yeah. Okay, that's circular reasoning. Okay, next question. An object can have a positive distance while having a negative displacement. And again, we're going to vote. Once again, how high you hold your hand up is how sure you are of the answer. I'm positive. I'm pretty sure. I'm only voting because Dueck is going to... Yeah. So you ready? Allie's thinking deep thoughts. By the way, it's always funny because sometimes when we vote, if a lot of people pick one answer, there's like 5 or 6 kids, and you'll see the delayed the peer pressure in action. It's great. Who says true? Oh, again, everyone. Wow. Convince me. Or give me an example. Sarah.
It's the same thing as the last one. So you mean,
Well, no, because 3 meters forward. Oh, okay. Same concept.
same concept.
Knock me out. What you got?
3 meters forward and 4 meters back. You travel 7 meters, but it's also like
Sure. I like that. And we could even prove it mathematically because we would call forward positive and backwards negative, and positive 3 plus negative 4. And holy smokes, now integers that you start learning in grade 7 and grade 8 have a completely different meaning. It's not just rules. Now it's actually, no, they have to work in the physical world, otherwise our physics breaks down. Thank you very much. Kind of nice. Next page. An object can have 0 distance while having a positive displacement. Ooh. Once again, we're going to vote. Once again, how high we hold our hand up is how sure we are of the answer. So an object can have 0 distance while having... By the way, we will be having little thought puzzles like this an awful lot all year long. So get used to trying to come up with a mental hypothesis or trying to think about an exception to the rule or trying to find a loophole in whatever. We're going to learn to develop your minds a little bit too. Who says true, Mr. Dueck? Absolutely. An object can have... Was that a vote? You sure? Because that looked like you started to commit and then looked around. Really? Okay. An object can have 0 distance while having a positive displacement. Everyone went 0? False. Convince me. Karn.
If you have zero distance and you have one distance, so you can go
Don't you have to go forward to change position? Well, I would argue I can go backwards to change my displacement too. So I think You're thinking the right thing, but whenever we're offering an argument, we have to pick our words very carefully. Convince me. By the way, we have a saying in logic and in reasoning, it's very difficult to prove a negative. And what we're trying to do here is prove that a statement is false. That's far, far, far more difficult. Convince me. Yeah.
If your distance equals 0, it means you're not moving forward. So you have to, because of the distance equals 0.
Is that good? If distance is 0, no steps. By the way, you could write if d equals 0, as long as you don't put a vector sign above it. I chose not to when I'm typing. Usually I'll write the word out, but if I was handwriting, I would abbreviate. One of my favorite comics is Foxtrot. The author, Bill Ammond, actually has his physics degree, and while he was doing his physics degree in university, he was also drawing a lot and doodling a lot, and his friends said, hey, this is pretty funny, you should publish this. And so now he's a syndicated comic all across North America. Foxtrot looks at a family, and in particular, the youngest boy, Jason, is a nerd, dear to my heart. So Jason is playing football with his older brother, Peter. And Jason says, okay, here's the play. Go 40 yards downfield, then turn left and go 20 yards, then turn right and go 25 yards, then turn right again and go 30 yards, then turn right and go 30 yards, then turn left and go 10 yards. Then turn left and go 15 yards, then turn left and go 20 yards, then turn left and go 50 yards, and I'll hit you with the ball. Peter does some mental calculations and says, won't I be right back where I started? Jason says, I can't throw very far. Peter says, okay, here's the new play. Jason says, I never get to be quarterback. Okay. First question, what distance will Peter run in order to complete this play? Well, I'm looking for every number. This is going to be in yards. I see a 20 plus, a 25 plus, a 30 plus, a 30 plus, a 10 plus, a 15 plus, a 20 plus, a 50. Which is what? I think I can do this in my head. 55 and 60 is 105, 115, 130, 150, 200? No. I missed one. I missed a 40. Did I miss a 40? Where did I miss a 40? Oh, I missed the first 40. Dueck. Oh, you know what the really neat thing about digital ink is? Watch, 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 watch. No one noticed. There. 240 meters? Yards? Yards? I think B will be able to do in our heads if he ends up right back where he starts from. What's his displacement? 0. We have on a sunny day once before, I've taken my kids into the back football field and we've run this and the physics works. You do end up right back where you started from, which is one of the things I always like about Foxtrot comics. If he brings in any math or physics, it's correct. So displacement will be 0 yards. What's your homework? So this is going to be a lot of conceptual, but you're occasionally going to be using distance equals speed times time, or displacement equals velocity times time, or maybe getting a different letter by itself. Number 1 is totally fair game. Okay. Number 2, in this graph, assume each little grid is 1 kilometer by 1 kilometer. So that's how you can work out your distances. So number 2 is fair game. Number 3 is fair game, but can you all look up, when I photocopied this and shrunk it down, you can't read the subscript, so this one on the left is the initial, and this one on the right is the final. That's why I drew a little I pointing towards it and an F pointing towards it. And same with number 4, because when I shrunk it down, you couldn't read the F's and the I's anymore, so the one on the left is the final, the one on the right is the initial, so 3 and 4 are fair game. 5, now we're starting to do some arithmetic. It wants you to find the average speed. You're going to have to get the V by itself. Kilometers per hour, you can use these numbers and then convert it to meters per second. Something to do with a 3.6, I can't remember. 6 is good, 7 is good, 8 is good, 9 is good, 10 is good. And I attach the answers on the very, very back. Why didn't you just say do every question? Because I wanted to walk you through it. You have the remainder of class, my joy.